Hi everyone, this is Navika, a cloud engineer and a Microsoft Most Valuable Professional in Azure. Welcome back to the 31st episode of Tech Chat with Navika as we dive into the Azure Compute services today. And for that, we have a very prominent and experienced speaker and professional with us today, Thiago is a principal cloud and an AI solution engineer at Microsoft. He's an extremely experienced tech expert with over extensive 20 plus years of experience in the IT industry, with over 12 plus years of experience in Microsoft Azure Cloud and a 10 times Microsoft Most Valuable Professional. As a principal solutions architect at Microsoft, he guides enterprises through secure, scalable Azure and AI transformations, focusing on architecture, migration, AI solutions, etc. He's extremely passionate about sharing his knowledge with the community, and I'm so glad to host him the second time on the podcast. Thank you so much, Thiago, for making your second appearance.
Yeah, thanks for inviting me once again. Happy to be here and sharing knowledge with your audience the best I can.
That's so kind of you. All right, then let's get started because I cannot wait to dive in the podcast along with you. So, as I mentioned in the beginning, today we are going to be talking everything related to Azure Compute Services, rightly starting from what, why, use cases to going to the architectural decision making. But actually, before we dive into all of that,
hmm
I think a good start to the podcast would be right from the basics. So, how would you explain like the core building blocks of compute to the audience, and why are they foundational to everything else in the cloud?
Okay, good question. Actually, compute is one of the core building blocks in cloud. Without compute, you cannot do anything. Like, for example, if you remember or if you check how everything started, it started with virtual machines. We only have virtual machines, we had virtual networks and storage. So those are the very basic core building blocks when we talk about cloud computing. And the compute part is actually what it's one of the main reasons for you to migrate or use the cloud, because you leverage the huge amount of compute capacity that exists in the data centers, and it will allow your application to scale and perform well. So I would say definitely this is one of the fundamental things that you need to master and to study in order to succeed with the cloud.
Absolutely.
Did I
Thank you
answer your
for
question?
yeah, you did. You did.
Okay.
I was supposed to say that. Thank you for. We have at least set the base so that we can move into the podcast further. So thank you for that.
Okay.
Um, so we have spoken about central compute, where you did mention about VMs, etc. But
hmm
if we specifically talk about Azure Compute Services,
hmm
would you like to throw some light on some different Azure Compute services that are offered? Like just a quick brief, maybe for each one of those, so
Yes,
that we just set the base for the following questions.
sure. So as I said, everything started with virtual machines, and then different abstractions were created on top of virtual machines. So basically, you delegate the control to the cloud provider. In our case here is Microsoft Azure, right? And then you just focus on smaller parts which are important to you. So for example, after virtual machines, uh, was introduced the Azure App Service, which is pretty much like the web server, and you pretty much say to Microsoft, hey, here's my web application, host for me. And then Microsoft will host, and you can set up some scaling rules. For example, whenever the utilization of memory increases to this amount, add another instance, and then Microsoft will load balance the request for you. Or whenever, for example, there's the increase on CPU usage, do the same, add a new instance, and Microsoft will route the requests to those different instances. And the opposite as well. So whenever the consumption decrease, go back to our previous number of instances. So that's elasticity. It's one of the beauties, in my opinion. And previously you need to do everything by yourself, and thanks to the cloud, you can delegate this to the cloud provider and just focus on the application, for example. Yeah. sorry, but this is the app service, right? We have other compute services. We have container apps, which is pretty much the same as app service, but consider that um, you have an application which is containerized, and then it will spin up or add a new instance really fast because the container is, a fraction of seconds, or even in the worst case, a few seconds to spin up way faster than a VM, for example. So um, if you already are using Kubernetes, for example, we have the managed service, which is Azure Kubernetes service as well. There are some very interesting other services like the Azure Batch and Microsoft Discovery. I think it's in GA right now, a focus for research and development, for example. So let's say you want to do really heavy computations, those services are designed for that. Um, what else? We have container instance. Container instance in container apps, they are kind of similar, but at the same time, they are different. So those two, if you just need to spin up a container, which will do some task, and then you dispose this container, you probably will go with container instance. But if you need communication between containers, then container apps is more, um, you know, a preferred choice for that.
Yeah.
Those are the ones that came to my mind right now. Probably we have more that will fall under
Mhm.
the compute, but those are the most common, I would say.
Absolutely, absolutely. Thanks for that, Thiago. And now that we do have, certain understanding of the services that you did mention about, right? Compute services.
Hmm.
I think now it's the right time we can move a little bit towards the architectural decision making sort of, front in a way. So like when designing solutions, how I know you did mention about VMs, you did mention about containers as well. And if we
Hmm.
take into the picture serverless, which logic app, function apps, etc. So
Hmm.
when designing solutions, how can one make that decision on what basis to decide between virtual machines, containers, or the serverless? So if
Yeah.
you can just help us understand that.
Well, that's actually hard to answer because it depends on many factors.
Yeah.
And whenever you choose one, you're giving up other benefits or other things that other service may offer to you. So it's all about trade-offs, and you need to balance what is more important. Like, for example, if you have really tight budget, you probably don't want to use Kubernetes or Azure Batch, depending on what you're trying to do, because there will be higher cost associated to that. So you probably will try to use some serverless compute service, either container apps or Azure Functions, as you mentioned as well, or logic apps, because they are charged based on utilization, right? Which is the number of triggers and the amount of compute associated with that execution. But at the same time, if you will receive, huge amount of requests and um, you know, latency is very important to you. Probably you may want to use a different service versus the ones that I just mentioned, because there's this code start issue, which is pretty much it takes some time for the container to spin up, for example, and to execute the logic that you implemented, right? And sometimes this latency is, critical. Like, just imagine, for example, if you are creating some self-drive solution for a car, and you plan to use some serverless um, service for that, right? Sometimes the you know the time to make a decision is very critical. Otherwise, the car will hit, right? So you cannot, deal with these cold start issues. It's not an option at all. So I'm just giving examples. Probably that's not the
No,
case for the audience, but again, you need to balance what is most critical in terms of requirements and functionalities and budget as well. So there's like different
multiple.
variables, and depending on what is more critical, you either go to one or other service versus
Yeah.
uh, different ones. Yeah.
Thanks for that. As I completely agree with you, second your thought on that, that there are different factors on based on which, it completely depends from use case to use case. But I
Hmm.
think you did mention a couple of factors in your answers, which is very beneficial to make this decision, right? Whether it's cost
Yes.
or whether it's use case, needs and requirements, etc. So
Hmm.
thanks for sharing that example too. Now moving a little bit more further, obviously you've been into Azure for years and years now. So if you were to, suggest or recommend some best practices in general concerning Azure Compute, so let me frame it in a question in a way that if we just talk about within Azure Compute infrastructure, whether we talk about virtual machine skill sets, AKS, OLS, what we just discussed, what are the architectural patterns or strategies that you would recommend to ensure resilience and reliability in general within your compute infrastructure that one
Yeah.
should apply? Yeah.
Okay. Good question. And that also depends on the RPO and RTO. RPO
Mm.
is a recovery point objective, and RTO a recovery time objective. So here at Microsoft, I'm dealing with very large organizations, right?
Yeah.
And they have different requirements on those areas. So it's pretty much some companies they cannot, stay like sorry, they cannot wait hours to recover, assuming there's a failure in a region, for example, or a data center, right? They need to, immediately move their compute or their applications to a different region in case it's not there as
Mhm.
fast as possible, right? Otherwise, there will be a fine or some critical issues will happen.
Yeah.
Uh, so for those cases, for example, they usually keep a warm replica of their applications in a different region, right, which is not affected. And if by any chance or any reason the origin or the main region is down, they immediately reroute the request to this copy, which is just in standby but ready to be used when needed, right? So this is one scenario. The other scenario is okay, and just one more thing on that. There's obviously a cost associated because you're paying for something which is not used. But again, it's the right choice for some companies because they cannot be, down by any chance. Otherwise, there will be penalties associated. However, if it's okay for the company to, stay a couple minutes, maybe an hour until you are moving things to a different region and leveraging infrastructure as code, for example, you can recreate your environment in a safer or in a region which is not affected. That's a better way to phrase. And then once everything is recreated, you just, um, reconfigure DNS and point to this new region, and everything will be ready to be used again. So those are
Mhm.
best practices and common workarounds to deal with possible failures and um, increase resilience and reliability of your applications.
Perfect. Thanks. And yeah, I do agree. I mean, just in a nutshell, what you just said, it's more related to, in a way, you're saying like having a disaster recovery region ready, right? That's one of the ways. And the second one is definitely your infrastructure as a code to have everything ready with all the variables and parameters. You just have to sort of click that hit button and have everything deployed. So,
Yes,
absolutely, I just second to your advice over there. Thanks for sharing that.
you're
Um,
welcome.
Now, as we are almost heading towards the end, so last one, two questions would be more generic ones. When we many individuals initially, if they're starting their journey in Azure, and especially with compute in a way, they start off with lift and shift migrations. Using
Mhm.
the virtual machines, which we spoke also a little bit in the beginning. How would you guide them toward a more cloud native compute services like app service or functions? So basically, what is required to move from more infrastructure centric to a service driven architecture is my question.
Mm. Um, I think about it, and that's a good question. So what I'm thinking is, um, sometimes a company is, hosting their applications in a data center. They have a lease, right? And then when it's a time for them to renew, there's increase on the cost, or for some reason they want to move out. So the fastest way is what you said, just lift and shift to Azure, for example. They recreate the VMs, and um, will be almost smoothly migration for them. Even if they use, for example, Azure Migrate, will be super easy to move from A to B, right? But then, as we said, they're not fully using the main benefits of the cloud, because if by any chance they want to add another instance to the farm, basically a new disk will need to be created, new um, installation of the operation system needs to happen, right? And
Yeah.
then the creation of the web server, and then copying the application. So all of that takes time, even though it's way faster than it used to be in the past. It may take a few minutes, right? So imagine, for example, during a Black Friday, a company using or hosting their e-commerce in a VM, and suddenly the number of requests increase a lot. Some users or all the users will face a slowdown because the VM will be over capacity, right? So ideally, they should migrate to some cloud native um, compute service, because this scaling will be way faster, right? As I said before, they will skip from the provisioning of the disk, from the installation of the operating system, to jump right away to the copy of the application, and then just setting the scaling rules, and um, configure the load balance to route the request to this new instance. So it will be way faster than just recreating or adding another VM. So it depends on the scenario, right? But I highly recommend, if possible, to leverage and use the cloud native services, because they will be, um, you know, will be less things for you to take control. That's mainly the message here. But in some scenarios, that's not possible. So, like for example, sometimes here I'm dealing with some oil and gas companies, and they have very heavy rendering of 3D models. This needs to be in a VM, or because it's legacy application, legacy everything. So they've been doing this for years and years, and just using a cloud native service may not be that simple for them.
Yeah. Thank you, Thiago. And but again, giving that background is always helpful. And as we have reached towards the end of the podcast. The last real quick question that I would like to take from you
Okay.
is, for those who are starting the journey with Azure Compute, if you
hmm
just give some starting, what do you call, roadmap as to how can they start off with it. Maybe just a brief 1 minute would also work.
A roadmap for people starting with
Just
Azure.
with Azure Compute infrastructures if they haven't dealt with it initially or something of that sort.
Okay. Um,
How should they start the journey is my question basically, even
yeah.
for individuals, not necessarily organizations.
Yeah. So I would say, as we mentioned before, there are different compute services under the compute umbrella, right? I would say
Yeah.
my recommendation would be to identify and map the possible ways for you to host an application, and then you consider, okay, when should I use, for example, app services versus container apps? What are the benefits? And you start this exercise, thinking about the trade-offs. What I'm giving control versus what I'm or what I'm losing versus what I'm gaining if I choose one or the other, for example. And then you do the same for the other compute services. This will give you like a North Star when to use what. Um, but of course, that demands or requires some previous experience. For people that are just getting started, I would say the easiest way is to just spin up an Epi service and deploy the application there, and then start playing with the scaling metrics, for example, scaling rules, sorry. If possible, try to output the name of the instance so you know that it's routing the request. And then, if possible, you can simulate, like, for example, some performance test, and you see the scaling happening, the scaling in and scaling out, which is adding more instance or removing more instance, for example. This will give you a solid um, foundation, for example. And then from that, you start using other services and try to replicate the same scenario, like, hey, how this scaling happens with this other service? Um, how much will it cost? Or how much will it take to add another instance? Or things like this, right? Because cost is very important as well. Of course, in the end,
Absolutely.
someone will need to pay for that, and they
Yeah.
cannot expect a very large bill, cloud bill, right? So this is a good start, in my opinion. And always, as we said, think about the core building blocks. So,
Mhm.
okay, I have a compute. I probably will need to communicate or interact with some storage, which is another building block. And this communication happens through a virtual network. So these all things are connected, right? And lastly, I would say the last building block is identity. How
Access.
I'm
Yeah.
configuring who has access to what. So this will be the Entra part. So if you have a solid foundation on those four pillars, I would say you are good to go, and probably you'll be able to navigate through different clouds as well if needed. So because this is like agnostic of
Yeah.
any cloud. If you master those
Yeah.
pillars, you'll be able to transfer or navigate through different clouds.
Yeah. That brings us towards the end of the podcast. And time flight. So thank you for that. And the podcasts with you are always very educative and insightful, as I always say. So thank you so much once again for gracing the podcast the second time. And I hope to see you again super soon,
Yeah,
if your schedule allows.
yeah,
And
I would love to.
yeah,
Thanks so much,
great.
Navika. And one last question, or actually one last message. If your audience would like to connect, just search for me on LinkedIn. I accept everyone, and I'll be more than happy to provide more insights. And looking forward for the next episode here in your podcast. Thank you, Navka.
Super excited, and likewise, and I completely agree. Thiago is one of the kindest MVPs. Like, he was an MVP, now he's working at Microsoft, and feel free to connect with him. So thank you once again, and
Thank you.